Hello, this is going to be one of my less exciting videos, but one of my more informative ones. I'm going to show you from absolute start to absolute finish how to make a wireless, individually addressable LED strip that is controlled by open source software that can interact with lots of other things. We're going to do part selection, we're going to order it, we're going to build it, then we're going to get the software all done. I made a guide similar to this a few months ago. However, I did it after I was done making the strip because I wasn't confident enough making it that I was doing everything right. That wouldn't be a good tutorial. I'm not going to show you how to do something without 100% knowing how to do it myself. But now I do. Enough. First is part selection. The first thing we're going to talk about is the board that connects everything, where power, in this case it will be USB, goes in, then Wi-Fi for wireless goes in, and then we have, well, this is where we'll solder the LEDs to. There are three choices that I can say both will work, and I mostly know the differences between. There are a lot of technical things that don't matter to me. As long as it works, but I'll talk about the differences that matter to me. First, we have the one that I am actually using to power the LED strip that I've already made. It's 6 by 3 centimeters, so it's the largest. It only uses micro USB, which is, it's a shame, but also you're not plugging or unplugging it often, so it shouldn't matter too much, but still USB-C would be nice. If you don't want anything special, just get this. Next is the D1 Mini V4. This is the best one from what I've seen. It has USB-C, which is really nice. It's nice and small. I swear this is like 3 by 3 centimeters. One thing to note, I think, is that the mini ones don't have the pins already on there, like as they show in the pictures. Comes with the pins separate, and then you solder them onto the board. Then, if you want just this but less fancy, there's the Pro V3. Same thing with the pins, as far as I can tell. Difference is it uses micro USB and is a bit older. There are actual technical differences, but you don't need to know them for this. So, basically, you want the fanciest one, you want USB Type-C, you get this. You don't care, you get this. You want a small one, you get either of these. Honestly, I'm leaning more towards this because I've already done this, and this is just small this, so I think that's where we're going to go, so I'm going to add it to cart. Next are the LED strips themselves. I have only ever bought from this seller. I can vouch that they have worked, and that's about it. But we're going to do it again. It says they're the AliExpress top seller. I'm not sure if that's as meaningless as it is on Amazon. Something to note, this didn't have any coupon stuff on it. This does. However, it also did first time I got it, so this might be something that's just constantly going on. It might not be. I'm not 100% sure. So you're probably going to want the black PCB, but white is an option. This is where it gets important. We're powering these LED strips directly off the board, and that means we're going to want to stay 100 LEDs or below. You could do more, and it would likely power it, but it's a little board. Just for safety, I want to keep it below 100, so power draw is not too much. If you would like to power it separately, you just need a 5-volt power supply, and you could even get a USB cable, right? Plug it into a USB power adapter, cut off the end, and then get the 5-volt positive and 5-volt negative, solder it to the end of the LED strip, and it'd work. All we need is 5 volts power. If you'd like to do longer LED runs, use a separate power supply. However, for this, we're focusing more on, you have it like a desk, or my room is only 2 meters wide, so I've got a 2-meter one here, that's 60 LEDs. That kind of thing. If you want a huge outdoor run, first of all, you should be using 12-volt strips instead, and second, a different power supply. However, if I ever do this, I will make another tutorial on that. So, the way you'd read it, I imagine you can already tell. 1 meter is the length, then this is the density, the LEDs per meter, and then the waterproofing rating. We don't care about the waterproofing. most likely. So we'll go with IP30. So I could get up to 3 meters 30. However, I could also get 1 meter 60 or 1 meter 96. Densities, if the LED strips are directly visible, higher density is better because there's less just strip that isn't LED visible. However, if you're like me, where you have them reflecting off something, or if you're going to have them diffused, then 30 is just fine. Unless you want to be showing like fancy patterns on them, in which case then like the steps the patterns go through, it'll be higher resolution. That's not going to matter for most people. So if you know you want that, go higher density. Just keep in mind, you can even do 144. However, not with this, because we're staying below 100 LEDs. So we could do up to 3 meter 30. I'm going to go with 2 meter 30, £5.22. Gonna add it to cart. These I intend to be smarter with this time, because either side, there we go, there are connectors. We've got these two. I'm gonna take the female one off the LEDs and actually put it on the board so it has a slot. So now we've got the parts. We've got the board and we've got the LEDs. The first thing we've got to do is flash this board so we can make sure that it actually works. And to do that, we're going to need some drivers, NODEMCU Pyflasher, and WLED itself. So, all of the links for everything you'll need will be in the description. First, the drivers, just click it, open with 7-zip, I extract it, I should say. And then once you've got it downloaded, you can just double-click setup.exe, don't plug in your board yet. Leave the INF, and just press install. Oh. And there we go. Once it's plugged in, make sure Windows actually makes a sound so that you know it's been recognized, and then head over to the NODEMCU Pyflasher page. Normally, I actually run Linux, not for this specific week, for something I had to do. So apologies for that, you can still do this on Linux. However, here we've just got some easy downloads. Use x64.exe for Windows and DMG for Mac. So in my case, run Windows 11. Save that. Download, yep, I know I've already got it. Then go to the WLED page, also in the description, and download the ESP8266.bin file. Yep. Now go over to your downloads, and click NODEMCU Pyflasher. This won't require administrator or anything. And then select the serial port. Since this is my second take, I know that this board uses COM3. However, my previous one, for my previous LEDs that I've already made, used COM1, so selecting the wrong one won't do any harm. So if you select a COM and then press flash and it does nothing, just close the app, open it again, try the other one. Now press browse and select the WLED file. You don't need to adjust any of this, because this is my second run. I will actually wipe all data, and then just press flash. As long as the program says it's writing and you can see this percentage going up, you're fine. Okay, and now the firmware's successfully been flashed, and there's actually just a little reset button. We can press that. And this LED is on solid, meaning WLED is definitely installed. But then, how do we interact with it? Especially since I said it was wireless. Well, you can actually go to your Wi-Fi settings. It can be on your phone. I'll do it on my computer so you can see. Okay, sorry, I've got Wi-Fi plugged in now. There we go. Go to your Wi-Fi and find the network that hopefully appears, called WLED AP. Never mind, I forgot. I actually told this Wi-Fi chip on my computer to only see 5 GHz. And you'll see WLED AP. Make sure not to set up 2 of these simultaneously, as they will both make a network called WLED AP. Anyway, click on it, and the password is WLED1234. And there we go, now we're connected. Now, there's obviously no internet access to this network. However, if you go to your web browser and type 4.3.2.1 and press enter, continue to HTTP site, we can see here's the setup page and it's running on this. Don't worry about it not being secure. This isn't the internet. It's just local to this. For now, we're going to leave it on this. We're not going to actually set it up, and that's because we need to actually test our LEDs. But before we actually do anything with this or set it up, you're going to want to unplug it from the computer, now we've tested it, and look at the pinout. So we want ground and data pin 4. How are we going to test them? Well, with my other ones, I would have stripped the wires and touched them to the pins on the board. The problem is, first of all, there are not pins on this board yet, and number 2, I actually intend to keep the ports on these working, the connectors. And so we're going to have to prepare the board. So this is going to be interesting to film. You can probably tell that my audio has gotten much worse. That's because the microphone is now far away. But we've got some solder. Mine is lead free. It doesn't matter. A soldering iron, which is very much plugged in, so don't touch it. The board and the LEDs. This is going to make it really awkward if you want to daisy chain them in the future. However, we don't. Because of the limitation of LEDs from these boards anyway, we're not going to be able to really daisy chain any. So this isn't a huge problem. The female end, remember the bit that pins stick into, the hollow end, just let's not take all the wires off. Let's take off just the ones for the connector. There. Okay. We now have the connector that's going to go on our board. So I've just separated the wires a bit. The red wire is for power, the white or black is for ground, and the green is for data. I appreciate that this is not being greatly filmed. However, there is not much to film. Like, you don't really want to see my soldering technique, and if you have a different board than me, you're not going to want to copy me directly because your pinout will be different. Just know, remember, white or black is ground, red is power. Okay, so that took a bit longer than I would have hoped. I made a mistake, and I actually ripped the wire accidentally out of the port, and I thought I was just kind of out of luck. However, there was a strand of metal. So I'd ripped out most of the actual metal wire and all of the rubber. However, there was one strand of metal that I then soldered a new wire to, and the connector works. And so I've put hot glue in just so it's more likely to stay connected. It's going to stay connected, even with just the solder, because no strain is ever going to be on that part of it. And the hope is it works. So we can just plug USB-C into one end. We've got the light. And then we actually find out if the LEDs work first try. Hey, success! But now we're going to actually configure the software, like I mentioned earlier. Alright, hopefully you can actually see the color of the light on my face, because that's how you're going to know that the colors are actually changing. But we're going to want to reconnect to WLED AP. I'm going to do that now, so you don't see all the Wi-Fi networks around me. And now we've done that, we can go to 4.3.2.1. Your browser may complain about it being HTTP. Once again, that's fine, this is a local site. And we're back on the welcome page. So we're going to go to the controls and make sure it actually works and that it's the correct order, because some LED strips might not be RGB, but BGR. So if we move over to red, it goes red, green, it goes green, blue, it goes blue, and everything in between works. And so here, we can actually change the brightness and everything, it all works fine. So now, I'm going to go back and go to the settings. First, we're going to type the name of the Wi-Fi network we want it to connect to. This has to be 2.4 gigahertz. We can look at the IP. So, most people will be fine leaving this how it is, DHCP. However, if you would like a specific IP address, and if you don't know what I mean by that, then you're just going to want to leave it as zeros. If you want to be able to access it from a specific unchanging IP address, here is where to put that. Next, you can set a local domain name if you'd like. So if you want to access this web interface, you don't have to type the IP address, you can type words. That doesn't work for me on my other one, so I'm just going to leave it. And then after that, is important for if you're setting up multiple of these. Change this. If your Wi-Fi goes down, so normally this Wi-Fi network that we're connected to won't exist because it will be connected to your Wi-Fi network, it will know that it's not needed. If your Wi-Fi goes down, these will then remake this so you can still reconfigure them. However, if you've got multiple of these, they will all make one called WLED AP, which means they're going to conflict. So, rename it. I could just put 2. I will actually name it something useful at some point. But yeah, so you can make it so no connection after boot. If it just disconnects while it's still on, even, you can have it always or never. It even says, I would not recommend always or never, but whatever you want, it's an option. And then save and connect. Now that the Wi-Fi settings have changed, we're not going to be able to connect to 4.3.2.1/settings/Wi-Fi. So you're going to want to go to the IP address you set, if you set one. So that's, which for me, I think is .20. There we go. And now this is connected to your router. Anything connected to your Wi-Fi router will be able to see this. And if you can't see it, you can download an app called Fing, and there is an open source alternative called Ning. You can download that on your phone, scan your Wi-Fi devices, and you can find the one that is WLED. It'll show you the IP address. You can just type that into anything connected to your internet connection, and it will appear here. And as you can see, it's just as controllable as before, but now we're not connected to its Wi-Fi. We're connected to everything else's, so our internet connection is also back. But now we've got some setup to do. So first, go over to Config and press LED Preferences. Now, you may have noticed and been a bit worried that your strip might have been broken, that not all of your LEDs are actually on if you have more than 30. That's where you change it. I've got 60, so I'll type 60. Now, make sure Enable Auto Brightness Limiter is on, and set this to whatever you'd want. This kind of mentions what I was talking about before. Keep it less than 1 amp. If you want to be more safe, if you want to prolong the life of the board and the LEDs, you can lower it. 800. I'm just going to put 800. It's a nice number, and I'm going to make it 5 volt efficient, just because. This is where, if your colors were swapped, like red was green, right? Like you press red on the color wheel and it goes green. This is where you fix that. GRB works fine for me, however, there's all of these options. And then I want the default brightness to be max, so change 128, which is half brightness, to 255. You shouldn't really need to change any of this. However, you can always come back if you would like to. Press save. Now, go to sync interfaces is important for if you'd like to control this with some software on your PC called OpenRGB. So you can actually control this with lots of things. You can use MQTT. I'm not really sure the best way to describe it. Home Assistant uses it. If you know what Home Assistant is for controlling smart home things, the Home Assistant, you can get some add-ons that use it. There's a bunch of ways of controlling it. What's important for us is E131. Turn on multicast, and then if you have multiple of these, remember to change the universe. So if you've got one, so I now have 2 with the building of this one. My previous one used start universe 1. Now I'll make it start universe 2. It could be any number as long as it's not the same number. Save. That's all I really need to do. Security and updates. You can press manual OTA update, and whenever there is an update available, so we can actually see that there are some betas with some new things, you can actually just download them off GitHub, then press browse, upload the file there, and press update. You don't ever have to plug it back into your computer. That's quite nice. I might actually update in a second. You can hide it behind a password if you'd like, and that's basically all we have to do from within there. And now to turn it into something you can actually use, there's not really many more steps. If you want to control it from your phone, you can just download the OpenRGB app, and you might have to type in the IP, which, like I showed earlier, that's how you can find it. Or it might hopefully just auto-detect it. And then you've got same menu as the web UI, but just it's a phone app. Or you can control it through LEDFX, LEDFX on your PC, which will make it react to audio. Also, OpenRGB, it has E131 support. I'll leave the page for that in the description, and then you can download the OpenRGB effects plugin. There's a ton of effects, including audio reactivity, although one current bug with OpenRGB seems to be that it can't control my two LED strips separately. I can make it control them both the same, but I can't make it connect to them separately. LEDFX has worked for me. It has been able to do both, but I prefer using OpenRGB. You could use Home Assistant and the MQTT support that they've got. You can control it in a bunch of different ways. So if you want it simple, then you can just be happy with the app. And that's it. We're done, I think. Hopefully you enjoyed. Maybe you followed along with this. Maybe now you have your own. I think the total price for this, including shipping, which took about 3 weeks, was £7.31, I think. I'll put the exact number on the screen. And compared to the first time I did this, the improvements are that the board is now much smaller, like half the length, which is nice. It now uses USB-C, and it now has a port, so you're not soldering the LEDs directly to the board. I think that's pretty good. Both generations actually, while controlling this with like OpenRGB, something where I can control both at once, they both take the same amount of latency. It being a different board doesn't affect compatibility between the two. I think it works really well. I'm a big fan of it, and you can even, I'm fairly certain, I will confirm on screen now, I'm fairly certain you can even get infrared controls if you do want to use just a normal remote for RGB. It's really flexible, it's open source, it's cheap, they're individually addressable, so the whole strip doesn't have to be the same color. You can do fancy effects with it. I think it's really good, and I hope you do too. Apologies for the boring video, but I hope you found it useful. Bye.